So let's start my algebras on this quadratic word problem. There's not a lot of people in here today. We're just going to go over some foundational examples. We're going to be skipping around the booklet right now. As such, let's get started on the first guy here because I want you, every time we start a new question, A, H, K, X, Y, Z1, and Z2. So those are Z's there. Reason why I say that is this is going to help us to start to identify how we'll approach each one of these questions. As in, I'm going to catalog what information I was given. So -5 and 2, -5 and 2. Those are the zeros that I have. For the xy, I have 3 and 16. So that is a point that I've been given. So if we're looking at a problem like this, do we think it's going to be a question in vertex form? Or do we think we'll be solving this in zeros form? Zeros. Exactly. So that's the main reason why I do this is just to label what I do have to try and assess what I can find from this guy here. So let's start to walk through this guy. The 3 and 16, -5 and 2. Okay, we're going to, now that we've identified that this is in zeros form, x minus z2, we are then going to plug all of those things in. So I'm going to plug in the y value I have. I'm going to plug in the x value I have. The first zero, the x gets replicated in zeros form, so I'm going to have 2 3s, and then I'm going to put the second zero in. Now we literally just math it up. So we're going to do internally in the brackets, 16 is equal to a, 8 times 1. 16 is equal to a times 8 divided by 8. A will be equal to 2. So basically all we're doing is labeling what information we have, choosing a form to work with, plugging it in, and then algebraic our way through to the answer. Now, I don't want you to just stop at a is equal to 2. I've had this confusion before where in past years I've said we're finding the rule of these guys. And then we find for a and then just kind of leave it at that. But the full rule now for this guy would be f of x is equal to 2 x plus 5 x minus 2. I can now use this guy for other purposes. Okay, this guy can now be used to solve for any other point on that function now. So my whole purpose of getting a is equal to 2 was so that I would be able to like have a rule that I could utilize to find other stuff. I could find H and K now if I need it. Like, if it's a great question there, Cameron. If they said right now, if there's a question that presented this information and said, okay, I now need you to find the highest point of this function, well, you'd be able to do that now. You'd be able to find the lowest point as well. Like, it depends on how it's phrased. Okay. So that's kind of like just like a first way to start thinking about it.
Wants it in general
form. Okay, yeah. Right now, let's just get the rule. Well, I'm just kind of running through these quickly. You would just FOIL that out and expand it, but you're right. It does ask for that, but let's just stick on find the base rule, and then we'll go from there. This guy here, E, a function with vertex 1 and -8, and one of the zeros equal to 3. Okay, so A, H, K, X, Y, Z1, Z2. So the vertex is 1 and -8. One of the zeros equal to 3. Okay, so that's all I have. Now, this guy's tough because you can solve it in both forms. You just have to be able to see it. So what I'm going to suggest, if you get a question that looks like this and you freeze and you're like, I don't have enough information right now, it looks like, to solve for it in vertex form. and I don't feel like I have enough information to solve for it in factored form. So let's just see if we can kind of figure this guy out here for a sec. Yeah?
The three should be between the two zeros because it says one of the zeros.
So we're saying one of the zeros. So like if I sketch this out right now, so 1 and -8. 1, 2, 3, 4, 5, 6, 7, 8. So that's it. And then 1, 2, 3, second zero. So there's the second zero. Okay. So if I sketch this guy out now, that's roughly what it's going to look like.
Okay.
So I know that this 0 is 3 and 0. I know that this vertex is 1 and -8. And sometimes it's helpful to kind of like sketch it out because you can start to reason through what certain things may be based off of the axis of symmetry. That's like a really important part of these questions, is that the axis of symmetry is 1.
Can I turn off the light?
Yeah, I know it's hard to see. The bulb is on its last legs. So,
No, it's just a very light green.
yeah. So from here, when I go to try and solve this guy, the one thing I want to point out to you here is that a 0 can also be a point. If this is my vertex, 3 and 0 is still a point on that line. There's nothing saying I can't use that in vertex form, where 0 is my y, a is unknown, x is 3, the h is -1, like when I put it into the formula, I'll say 3 minus 1, squared minus 8. And then I can solve for it this way, right? So when you go to solve this guy, my biggest piece of advice for you, and I want you to like procedurally like write this down, is move that k first. Otherwise, you'll screw it up. People will leave it there and combine it with what's going to happen next. But I'm going to move that first. So 8 is equal to a, 2 squared.
Excuse the interruption, but the students that attended the Algonquin trip are just on their way in and should be back shortly to your classes. So we will mark accordingly. Thank you. Bye-bye.
Okay. So from there, I'm going to divide by 4, divide by 4. A is equal to 2. So that means the rule for this guy, f of x, is equal to 2, x minus 1 squared minus 8. That's the rule in vertex form, but that doesn't mean I have to solve it in vertex form. I could use factored form. And this is where, can you see how that would work? How would it work that this would be done in factored form? Can I, because here, let me ask you this. How do I get my second 0? And the hint I'm going to give you is axis of symmetry.
So it would be -3? No, it'd be -2.
Why is it negative? Why would you say -2? And would it be, are you sure on -2?
No.
What is it? So here's all you're going to do. If there's the axis of symmetry and there's the first 0, let's just zoom in here. It'll let me do that. There we go. The distance from here to here is 2. So the distance from the axis of symmetry to the first 0 is 2. The distance from the axis of symmetry to the other 0 also has to be 2 because it's symmetrical. Meaning this guy here would be 1 minus 2, so -1 and 0 would be that 0. So now I can take the 1 and -8. Yes, it's the hk, but in this case, it's not necessarily going to be the hk. I am going to use it as an xy because it still is a point on the line. So it's weird that it can kind of be two things and serve two purposes. But now I'm going to plug things into my factored form. -8 is my y. A is what I'm looking for. The x is going to be 1. And then I'm going to have +1, 1 minus 3. Negative 8 is equal to a. 2 times negative 2. Negative 8 is equal to a. Negative 4. Divide by negative 4. Divide by negative 4. A is equal to 2. Got the same answer both times, but this was the answer in factored form, and this is going to be the answer in plus 1 x minus 3. That is going to be the answer in factored form. So it's entirely choice based, and that's what makes this unit so difficult. Is just that your approach to it can be different. You're still going to get the right answer, and you can logic your way into a form that you prefer. So the reason why I show you both is some of you may prefer solving for a in factored form, because I will say it is easier and it's prone to less mistakes. So if you can see how to get that second zero by using your axis of symmetry, you can work with a form that you may prefer, if that makes any sense. And I'm going to stop that one there.